we go. Let's talk about tans. Something we don't have because it's winter in Michigan. All right. That's true. The sun angle isn't high enough yet, though. So, something we need to remember about tangent. Graphing this is going to be vastly different in two aspects. What was true about cosine and sine when I graphed it on my domain? It was continuous, and my domain was all real numbers, right? So that's going to be different than tangent. The other thing I want to remember is, what does tangent actually mean? What was tangent? Y'all can't see in the video, but whatever. Remember, tan is what? Yeah, but it's also my slope, right? It's my y over x, or it's also called sine over cosine, right? Because that's my x and my y. Now think about this. Does tangent exist at every point on the unit circle? What happens right here? I have a slope of 1 over 0, which is undefined. So is tangent continuous across all real numbers? No. So this one's going to have asymptotes, right? Yes, they will be vertical asymptotes because the bottom's 0. Good. Some things to remember or highlight. Tangent is sine over cosine. So when cosine is 0, the slope, or there is no slope. It's undefined. Tangent curve is a new term we're going to use. You're going to see what that looks like. It has a distinct shape. Oh, and it's y over x. Okay, cool. It's everything I just said. Let's do an example. That I already did on a video yesterday. No, it was my own tomfoolery which led to my mistake. No, because this will be better because I had the unit circle up now. I didn't in the video. Because I'm doing more examples, I'm going to teach it better.
That was a trial run.
I made a joke that's not good on it. All right, yeah. All right, here we go. Let's go through and figure this out. How do I find tan of 0? Tan of 0 is 0 over 1, right? From my unit circle. So what's 0 over 1 equal to? 0, like the amount of money in my wallet. So now this one's going to be 1 over 2 over root 3 over 2, right? You guys remember that from back in the day? Because it's my y over x, my sine over cosine. And my sine was a half. So now, I'm not going to develop all of these, but that's 1/2. That becomes 1 over root 3, right? Which is the same thing as root 3 over 3. I didn't do this part in the video. I just went through and gave them to you. So that's root 3 over 3. At pi over 4, what's root 2 over 2 divided by root 2 over 2? 1. At pi over 3, it's root 3 over 2 over 1/2, which ends up being root 3. At pi over 2, it's 1 over 0. So what's that mean? When I divide by 0, it's undefined. It does not exist. Yes. No dice. All right. Now, over here, I'm going to follow the same pattern, but what's going to change is they're all going to be negative because I have a positive and a negative. And I'm just going to go in the reverse order, right? Because remember, I'm just hitting them on the way down. And 0. So again, we're going to have our key points, right? I can think of this as my key points. But what's nice about tangent is actually we're going to have asymptotes, a 0, and a curve. And I'll show you that. So where is this increasing? From 0 to this, am I going up? So I'm going up, right? You agree I'm going up from here to here. So from 0 to pi over 2, I'm going to put a parentheses there. Why not a bracket on this? Usually, Ms. Twilliger usually said increasing decreases is always a bracket. Why am I using a parentheses here? That's an asymptote. I can't touch 1/2, right? I don't want to touch it. Watch. Whoop. Ow. All right. Now on this side, am I increasing? I am, because they're negative, right? 0 is bigger than negative root 3. Negative 1 is bigger than root 3. So I am increasing on both of them. I'm actually increasing. I'm increasing everywhere that exists in the domain. So tangent is always increasing. Always increasing.
So what do you mean increasing?
I'm sorry, say it one more time. I can't hear. I'm old.
If you're in the third quadrant, are you increasing?
You're always increasing. You'll see when you see the graph what I mean by that. But yeah, tangent is always increasing across its domain is what you would say, right? Because it doesn't exist. Oh, so that's C. It doesn't decrease. It's always going up. Because if I go and start listing points, what's it going to do? It's going to repeat over and over again, right? These same points are going to be the next row because it's a periodic function. So tan is always increasing. Like me on a cruise ship. My tan's always increasing. Yeah, like me at a Flow Rider concert. Never decreasing. All right, let's take a look at this beast. Oh, this is going to be a lot harder. The video actually did a really nice job on this one. It's going to do a better job than I can do. Because I zoomed out and was able to show everything at once. All right, let's graph it. Using our points from before, let's graph those points. At 0, where do I put a dot? 0. At pi over 4, where do I put a dot? 1. At negative pi over 4, negative 1. What happens at pi over 2? Does it exist? What's that make? An asymptote, a vertical asymptote. So that's 1 tan. Now when I draw a tan, it looks like x to the third. You guys remember x to the third? So it's going to be concave down here and then concave up over there. And that's a tan line. I know some people think you only get tan lines like when you go outside with like a tank top on or like, you know what I mean? But actually you get tan lines by graphing this. All right. But now they want me to graph more. Something we need to know is what's the period of tan? Now notice on the unit circle, sorry video, I repeated after half a unit circle, right? So my period is pi. My period is not 2 pi, it's pi. That's a difference between tan and cosine tangent. So that means what can I do? This 0, 0 will occur every pi. So I'm going to put my 0, 0 every pi. So that's 1, 2, 3, 4 blocks. So where's my next asymptote? 1, 2, 3. Yep. And where's my other asymptote? Negative 3 pi over 2. So once you graph this central one, you just keep moving it over whatever the period is. Okay? And then this one will go here. Just shift it over. You're just moving everything over. And you're drawing your beautiful tans. How many of these tan lines are in a graph? Infinite, right? These actually look really neato when you zoom out because there's just an infinite bunch of like asymptotes and crazy stuff. Now, the question is, how many do I usually graph? A lot of times when you graph, you're going to get 3 in there. You know what I mean? You get your main one and one on each side. Depends what they ask. So I did that. Oh, what interval? What interval am I continuous on? Okay, what do I need? How much do I need to show one whole tangent curve? 1 pi, but they want to know what actual points do you need. And from negative pi over 2 to pi over 2. This doesn't, just know when you're graphing it, you go from one asymptote to another, you'll get one full graph in it, right? And that will tell you what you need to know. What are my points of inflection? Yeah, they're your 0 points. Because over here, you're concave up, right? Over here, you're concave down. So your points of inflection are your intercepts. Your points, just like where were your points of inflection on sine and cosine? They were your midline, which was your intercept. So if I move them up or down, it's at midline, right? So that's the same. So if I wanted to find all the points of inflection, what would I do? Well, it's when x is 0 plus my period times k, where k exists as an integer. Get used to that. We're going to be seeing it all the time. Well, k can be negative. It can be -1 or 2. What? That is Greek. That's epsilon. That is Greek, yeah. Actually, is that capital Z in Greek? No, I don't think it is. No, capital pi is this. That's summation of multiplication. That's a fret, yeah. All right. Let's see if I can do this. Pull this off. We'll try it. I'm going to leave the graph up here to help us answer these questions. All right, now, for my, actually, you guys, I'm just going to redraw a sketch of one of these. People love it when I do this at like dinner parties. All right, so that's a sketch of one tan. That'll help me answer the questions. What's my domain? Is it continuous across all real numbers? No. So what do I worry about domain is what can't x be? So I would write it as x cannot be what, pi over 2, right? And how often does that repeat? Every pi, k, where k exists as an integer. Now, if you don't want to write the symbols, could you write where k is an integer? Yeah, you can. That'd be full credit. Does this cover everything that x cannot be? Yes. What's my x-intercept?
0.
So I have zeros. Yeah, you can think about, I'm going to write 2 ways. 0 plus pi k. 0, right? Where k exists as an integer. Restricting your set matters. Now, could I just put pi k there? Yeah, because 0 plus anything is my money. Very much so. You can use n too. Some books use n, where n is an integer, but you do have to say n is an integer. Because if you just put a k, it could be a decimal. It could be anything. Is this even or odd? Remember, even means it can fold on itself. Odd means you can rotate it 180. It's odd because it has symmetry about the origin. You guys remember that from a long time ago? It just means if I rotate it. We didn't talk about, it was there. Remember, cosine is even because it flips on itself, and sine is odd because it rotates on itself. What are my key points? So when I graph, remember our key points are what we graph each time. I'm going to graph an asymptote. I'm going to graph, what did we call it in here? I'm going to graph, that's not a low point. We're going to graph one low point, an intercept, one high point, and an asymptote. So asymptote, I'm calling that the low point and that a high point. Okay. So you're going to asymptote, and then it's going to be like a little thing going up, asymptote. Now, for cosine and sine, my range was not, my range was my lowest point to my highest point, right? For this, what's my range going to be? Negative infinity, positive infinity, or all real numbers. Remember, both those are acceptable. What's my y-intercept on this? 0, 0. Why isn't there infinite y-intercepts? Because it only crosses that one once, right? Infinite x-intercepts, not infinite y. If you had more one y-intercept, is it a function? No, it'd fail the vertical line test.
So if it's a set of stuff, and if it's a set of attributes, it's not a
Yes, you can have a tangent function without a y-intercept, right? If I shifted this over and the asymptote was there, it would never cross the y-intercept. You can't rotate tans. Well, you'll see. You can rotate 180 but not 90. That's not a function. It doesn't exist. But yeah, it would not be a function. All right. That's everything I did yesterday in the video. Redone now. Even better. It wasn't bad. All right, let's graph a beast. Uh-oh, graph a negative tan? Mamma mia. So, do you remember our A sine, like, our A, whatever? This is going to hold true for tangent. Oops. This is going to be exactly the same like what we're doing, like our shifts and stuff. They're all going to be the same. Yeah, I mean, are we moving left, right, up, down? Yeah, I mean, that's not going to change. Do we have an amplitude we can graph, though? No. This number's not going to do anything we can really see that much. You know what I mean? Like, so, let's graph our, how do you guys want to graph it? Do you want to use the 5 points? Do you want to make a chart? How do you want to do it? 5 points? All right. So I need to start with an asymptote. Is my asymptote moving left, right, or anything? No. No. So my asymptote is going to be at my pi over 2's, right? Oh, wait. I should have done this first. What about my... Well, what's my period going to be? It's going to be pi over b, right? Not 2 pi over b. And what's b on this one? 1, right? So my period is pi. Now my low point is usually what? Negative pi over 4, negative 1, right? If that's negative in front, which one of these is going to change? The negative 1 is going to become a positive 1. So my low point goes from that to that. Yeah. So it's going to go up here. Is my intercept going to change? No. Negative 0 is still 0. What do you think my high is going to become then? My high becomes my low. And then I already graphed the other asymptote. So I graph this, it's just going to do this. You just repeat the pattern. Make sure your zeros are every pi. Because what we know, what's a negative do in front? Flips it. Is that flipped? Yeah. What else did it want? Oh, describe the behavior. Oh. If A is less than 0, it reflects over the x-axis. Forgot my watch today. Yeah. Yeah, we do. It's a long one, though. This will, I'll actually finish the whole thing in one thing. You're going to watch this video, and I'm going to give you guys time to work day. Yep, it's going to be a work day, and then watch the video. I have to make the video now because I incorrectly. So today's going to be a longer lecture. All right. So again, it's kind of a review of what we just did. There's 5 key structures, right? There's 5 key structures. We find our 2 consecutive asymptotes, find the x-intercept. Now what's nice is, let's say so this is kind of like, how do we come up with the equation for the graph? You find your asymptotes. Your x-intercept is always right in the middle, right? Okay. So your x-intercept is always right in the middle. And we did that with sine and cosine, right? Like cosine, we did our two maxes. The min was in the middle, right? Sine, we did 0, 0, 0 in the middle. So this one, we have asymptote, asymptote, x-intercepts in the middle. Now this has 1/4 and 3/4, but this point is what? I don't know what that is. It's halfway in between, right? And this point is going to be half and half, right? So this way teaches you go 1/4, half, 3/4. I do cut it in half, and then cut it in half, and cut it in half, right? You can do that with sine and cosine, right? Cut in half, cut in half, cut in half. It's like cutting a pizza. Phew. Ooh. I don't do it that way. But think about this as your left point and your right point. Or your asymptote. Never mind. So if you want an equation, put a star by these. These will give you your asymptotes. Left and right. Bx minus c is your asymptote every time. So if you want an equation where you don't have to think, what's my asymptote going to be? There it is. Left and the right. So for this one, it's negative pi over 2. Jiminy crickets. Okay. I don't use the equation. I just kind of use my intuition. But there is an equation. We just talked about this. Do we really need this again?
No.
Yeah, we do. This is for the sophomore. He just told me, Mr. Terwilliger, this is way not repetitive enough. So what's my, I'm going to give you an equation for domain then too. If bx minus c gives me asymptotes, my domain is whenever bx plus c doesn't equal 0. Right? Right? I don't know. All right, I might disagree with this one. Remember, because it's tan. Right? So if that's my asymptote, that's what restricts my domain. What's A give me? A vertical stretch. There's only 2 points that's going to affect, right? My low and my high. Nothing else is affected by a vertical stretch. Oh, there's a line here. My range is still infinity to infinity. Will that range ever change for tangent? No, it has to be. It has to be infinity. Key points we taught. Ooh, watch this though now. My career in a nutshell. All right, so we have an asymptote. Oh, it knocked it, it broke it. An asymptote. Negative A will give me my low point. Whatever my A is will tell me how far down or up I'm going to go for that low point. Do you know what I'm saying? No, asymptote to negative A, to intercept, to A, to asymptote. So now if I go back and regraph that other equation, I can do it really quick. Or no, if I had a number in front of tan, I can graph it really quick now. Find my period for my asymptotes. 0 is going to be 0. And then whatever the number is in front, whatever the number is in front. Absolutely not. What's my period now with that equation? It's pi over b. All right, let's do it. Watch this though. This is gonna be amazing. It's gonna be the best day of your life. It's gonna be the best March 4th, 2024 you've ever had. I don't know much about dates. I'm not accustomed to having them. All right, so let's graph this beast now. Negative tan of pi over 2. What's my a? Negative 1, right? A is negative 1, like if I pull it out. What's my period? Pi over a half, which is 2 pi, right? Anything too scary. Now, if I use my 5-point method, I gotta find my asymptote first. So my asymptote, if you want to, could I do my b of, what was it? I don't use the equation. Bx minus c as whatever. Set it equal to a half, and we solve it. I'm not gonna do that. What's my period? 2 pi, right? Is my intercept's gonna be 0, 0. There's no shifts. 2 pi is my period. Does that mean it's gonna be at pi? So you can think about it this way. Where's my next 0? 2 pi. So it means my asymptote has to be in the middle, right? What's in between 0 and 2 pi? Pi. Negative pi. The other thing you can think of is this. If my period's 2 pi, half of it is on each side for the asymptote. So what's half of 2 pi? Pi, negative pi. The only reason I showed you this way is if we start getting shifts, sometimes I actually will start with zeros and then cut them in half because the asymptote's in between. Or sometimes you can find the asymptotes and cut those in half. Just know that they're cut in half. Now, I have an asymptote. What's my next point? Is negative a. So what's negative 1? 1. So when I cut this in half, I go up to 1. Right? Intercept, I found it's halfway in between. And then my next point is positive a. So I go negative 1. And that has to be halfway. And I go negative 1. So you see how there's actually less to find on tangent graphs than there's sine and cosine. It's just different. Is that enough to graph it? Yeah. Yeah, but you have to find, there's 3 points and 2 asymptotes. Yeah, it's still. Just remember, you're always cutting stuff in half, you know what I mean? Like everything's in the middle of something else. There's a 0 there. Oh, down. Maybe are you down, 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 down. Whoa, whoa, whoa. That was bad. That's not good. That's. Oh, gee, whoa. Jiminy Crickets. All right, let's do this one rapid fire style. What's my A on this one? 1. What's my period? 4 pi. Oh, no. Just 4, right? Yeah. So my period's 4. So where's my first asymptote going to be? At negative 2, right? Because it's half of my period. Negative 2 and 2. Look at that. Did I shift is my intercept still at 0, 0? Did my low and high point change? So I cut that in half. Cut that in half. I don't know, honestly, tangent isn't that bad once you do it a bunch. Yeah. Yes. Yeah, this one went. So think about this. A negative A means it's decreasing the whole time. Positive A means it's increasing. That's a good way to self-check yourself. Self-check. Yeah, everything. Yeah, you can find anything. This is in between. No, usually when I teach tangent, it goes well because it's more into, like, you can look at pretty quick. There's no amplitudes to deal with. What's up? Oh, because my period is 4? So if I have a 0 here, I'll have a 0 here and a 0 there. from the equation, it's pi divided by b. Not 2 pi anymore. It's always pi for tangent, cotangent. Oh, that's bonus video work. Did I get done in time? Ooh!